8th graders, today your assignment is 3.5 magnetism. So this week we're kind of shifting our focus, and the bulk of our discussions and labs and stuff this week will be on electromagnets. So your learning targets for today are I can explain how an electromagnet produces a magnetic field, and I can explain how energy changes, so potential and kinetic energy, when magnets are moved against and with magnetic fields of electromagnets. So really looking at those similarities to how an electromagnet is similar and different from regular magnets, and how we can kind of use what we know about magnets to make predictions about electromagnets. Okay, you guys have 2 days for this assignment, so today and tomorrow. Obviously, if you guys get this all done today, you guys have time to either work on missing work or other work for tomorrow's class time. But moving on to activity 1, so quick little add to your notes today. You guys will go into OneNote, open up your magnetism section, and then go to your vocab page and add this definition and picture of an electromagnet. So an electromagnet is a type of magnet in which the magnetic field is produced by an electric current. So here is what an electromagnet looks like, where we have a battery, we have a current from that battery throwing through this wire around this little nail and then back to our battery, and then you guys can see that that nail acts as a magnet, excuse me. All right, moving on to your warm-up. You guys should have already completed both of these, the addition to your notes and this warm-up. You guys should have watched this video, so right-click it. Your video looks like this, okay? And you guys should have answered these 2 questions. How are they similar and how are they different, okay, to magnets? So if you guys haven't done that, take a second to pause this video right now and go back and do this. All right, which brings us up to the correct spot. So if you guys are watching this video, you are my green group, okay? If you still aren't sure if you're on the right spot, you guys should have clicked right here. So right-clicked, open link, and it should take you guys into Amplify. And the first thing you guys see in that is this strip of color right here. It should say green group if you are in the right spot. If it says blue or purple, you guys are in the wrong spot. So I want you guys to kind of switch gears. I want you to choose a different video and either watch blue group or purple group. But for those of you guys who are in the correct spot, this is what you guys are completing for today's activity. So you guys will be completing slides 2 and 3, which again you should have already done. You should have done your notebook edition and you should have done your warm-up. And then you guys will complete slides 17 through 25. So if you look over on the left here, you guys can see that slide 17 is switched to a green color. That is you guys. So everything that has this green background, 17 through 25, those are your guys' assigned slides for today. Okay, and then finally you guys will notice that everyone is assigned 33. That is your post-lesson wrap-up, so make sure you guys do that as well. But let's go ahead and get into our green slides here. So slide 17. What you guys are doing on activity 3 is you guys are going to make some predictions about these scenarios, and then you guys will test them. So slide 17 is your prediction page. You guys will use the draw tool for this, and you guys will use that to make your predictions. So predict. Imagine moving the bar magnet 3 grid points closer to the electromagnet in each setup. In which setup will potential energy change more after the move? So really what you're looking at here is you would have a value for your potential energy for this magnet placed 1, 2, 3, 4, 5 grid points away from your electromagnet. If we were to take and move that 1, 2, 3, so move it to right here, okay, we would probably change, well, we're going to change our potential energy. Do you guys think that's going to increase or decrease your potential energy moving it closer? Okay, at this point you guys should say it should increase your potential energy. Okay, so we have this increase in potential energy here in setup 1. Now in setup 2, we're 9 grid points away. Okay, everything about our electromagnet is still the same. We've just moved our weak magnet further away. So if we recorded the potential energy right here and then moved it 1, 2, 3 to right here, okay, we would obviously also increase our potential energy here. Which one do you think is going to have the highest increase of potential energy? Setup 1 moving from 5 to 2, or setup 2 moving from 9 to 6, okay? So circle your answer, setup 1 or setup 2, and then I want you guys to click and type in here to answer your guys' question. At this point, you guys have done enough with this vocab and really understanding these concepts that you guys should be able to formulate a pretty educated guess as to why that's going to happen the way it is using good vocab and good science. Okay, but moving on, we're actually going to test that theory. So whatever you guys circle for setup 1 or setup 2, we're going to test it out. So this is going to look a little bit different than any of your guys' other simulations that you've done. So first off, you guys will need to make sure to open your simulation. Remember, if you guys are trying to click on something and it's not clicking, It's probably because you guys didn't click off your draw tool. Okay, so you're going to open the simulation, launch the sim, switch to electromagnet mode, and turn the field lines on. So here's my sim. Up in the upper left-hand corner, I have these 3 horizontal lines. I'm going to choose electromagnets, and I'm going to load up the electromagnet mode. Okay, back to our directions. In build, place the electromagnet A as shown in both setups. Electromagnet A should be placed vertically and not rotated. What that means when I say not rotated is you guys pull it directly out of that toolbox and you don't flip it around. Okay, you leave it just how it was aligned in that box. Be sure to lock the electromagnet in place. Press run, then analyze. Drag 2 sensor tools to determine the force strength. Okay, we're only going to do one. I'm only going to show you guys setup 1. I'm going to help you guys collect data for setup 1, but you guys are going to be completely on your own for setup 2. So here's my electromagnet. I'm going to lock it in place, click and drag the lock. And then what it tells me to do is just go right into run and analyze. So we really haven't built this system here because we just have one magnet out here. The only thing that we're really missing from this is my field lines. Okay, so now that I'm in analyze, what I can do is I can test and collect data for the magnetic force that's present around this magnetic field. So even though there's nothing next to it, it's not a system, we still have a force available. We could potentially still have a system. So I'm going to click and drag this little sensor down here, and I'm going to place it 5 grid points away, which is where we would put our first magnet. So 1, 2, 3, 4, and 5. So what this is doing is it's giving me a reading for the magnetic force at the position where we're going to place our first magnet for setup 1. So it says 0.8. So I'm going to go into my next slide where I have my data table, and I'm going to plug in under force strength for setup 1 at 5 grid points away, 0.8. Okay, I'm going to let you guys move that same sensor to 9 grid points away. So you guys would move it right here to this spot. And I already snuck out a little answer for you guys. So if you saw that, you guys will record that answer. If not, move it and get your data. Okay, and then what we're going to do is we're going to go ahead to collect our potential energy before our move and our potential energy after our move. So what that means is if we were to place our magnet 5 grid points away, what's our potential energy? That's our before. And then if we were to go ahead and move that magnet 3 grid points closer to our electromagnet, that's our after move potential energy. So what's the potential energy at that point? Okay, so back to our build. I'm going to grab a bar magnet and place it 1, 2, 3, 4, 5 grid points away. Okay, and then I'm going to record my potential energy. It's okay if you guys just go 907. You don't have to worry too much about the decimal point. Okay, so 907. And then let's go ahead and move our magnet 3 grid points closer and get our potential energy there. So 1, 2, 3. Okay, our potential energy there is 1,169. Okay, and then it asks us to find the change in potential energy. So obviously we notice that when we move that magnet closer to our electromagnet, we increased our potential energy. So you guys are going to find how much it increased by. So I pulled up a calculator here for you guys. Okay, I'm going to go ahead and clear this off. 1,169 was our after. It's our higher of the 2 number. We're going to see how much it changed by. So subtract 907, which was our before. And you guys should come up with 262. So by moving that magnet 3 times closer to our electromagnet, or 3 grid points closer, we increased the potential energy of that system by 262 joules. Okay, do the same thing for setup 2. Okay, you guys are going to start 9 grid points away. You're going to record your potential energy, and then obviously when we move it closer, we're going to increase our potential energy. So we're going to move it 3 grid points closer and then see how much our potential energy increased by. Okay, compare those 2 numbers. So this column right here, which one's larger? Okay, that one's going to tell you that if we go back to our prediction and say, imagine moving the bar magnet 3 grid points closer to the electromagnet in each setup, in which setup will potential energy change more? So it had the biggest change, the biggest increase after the move. So did you write setup 1 or 2? Okay, now look at your data. Which one did it actually change? Which one's higher? Was it setup 1 or setup 2 that had the highest change? Okay, and then you guys obviously need to finish that data table there and then circle your answer. Were your predictions the same as your results? Were they different, or did you have like some that were okay and some that were incorrect? Okay, so answer those questions there. And moving on to our next simulation setup. You guys again are going to be making predictions. So here's setup 1. We have an electromagnet with an iron bar. And then we've taken that exact same setup, except we've just flipped this electromagnet 180 degrees. So it was facing like this, we turned it like that, okay? And then you guys have, again, an iron bar the same distance away. So the only change in this is that bar electromagnet has been flipped 180 degrees, okay? So your predictions. For setup 1, do you guys think the iron bar will move toward the electromagnet or away from the electromagnet? Okay. Setup 2, do you think you'll move toward the electromagnet or away from the electromagnet? Okay. And then last but not least, based on what you guys predicted for your toward or away, how can you make that potential energy as high as possible? So if you predicted toward, all right, I think this is going to move this way, what would you guys do to make that potential energy higher? This goes back to thinking about, are we moving with or against our magnetic field? Just as a reminder, if you guys are moving in the natural direction that those magnets want to move or that bar of iron wants to move, you're moving with it, okay? If you are moving against it, you're moving in the opposite way that that iron bar or those magnets naturally want to move. So think about which one of those, with or against, actually increases our potential energy. Your answer should be against, right? If we go against that, we're going to have a little bit more potential energy in the system to a point. Okay, so go ahead, check through those two things. And then, again, tell me how you guys can increase that. You guys may or may not have the same answers for these. Okay, it just all depends on whether you chose toward or away. All right, now, of course, we're going to test that out. So launch your sim, switch to electromagnet mode, turn your field lines on, create setup 1. Again, they're about 4, for this one, they're about 4 grid lines apart. Electromagnet A should be placed vertically and not rotated. Lock it in place. And then press run and observe the movement of the iron. I'm not going to show you guys this one, okay? You guys can figure this one out on your own. I'm just going to show you guys the setup. Here's my electromagnet. It's locked in place. I didn't rotate it. I grabbed it right out of here. Here's my weak magnet, 1, 2, 3, 4 away. Again, that north side is facing up, or the red side is facing up. And then I would go ahead and click run and watch what happens. Oh, excuse me, that's not supposed to be a magnet. It's supposed to be a piece of iron. There we go, 1, 2, 3, 4. So there's your piece of iron, okay? You'll do that for setup 1, and then for setup 2, you guys will flip your bar magnet or your electromagnet, and then you'll lock it in place. And then you guys will go ahead and again run that and see what happens. Okay, so here's where you guys collect your data from the sim. Did it move toward or away? And then what did you guys do to make it? So mess around with it now that you guys have figured out whether it moves towards or away, if it's different for either setup. And then how can you guys make that have the most potential energy? So mess around with that in the sim and see if it's whether you're moving it with the magnetic field or against the magnetic field. And then furthermore, don't forget to fill out your table and answer this question here. Were your results the same as your predictions? If you need to, make sure you go back and review what your predictions were. Okay? Last little section here is activity 4, where you guys have a setup similar to what you would see in the simulation. You're going to observe some things in the diagram, and then you're going to answer questions on the next slide. I just want to point out a couple things. So notice that your electromagnet is turned on. It has a magnetic field because it has electricity flowing. Notice that this one's further apart. Both of them are north side up. And really pay attention to what you guys see these field lines doing. Are those field lines indicative of 2 magnets that are repelling or 2 magnets that are attracting? Okay, so check out all those all those things, and then you guys will go ahead and move on to the questions on the next slide, which look like this. Simple, circle the correct answer. So immediately after it is released, will the magnet move faster in setup A or in setup B? So which one, A is further apart, or B? Which one do you think is going to move the fastest? And then the last little activity on slide 25, your last green slide, is this little vocab matchup. So you guys have a statement that you need to complete, filling in the blanks with vocab. So when the blank is turned on, it will have, so our first one would be electromagnet. I'll just help you guys get started. Notice how I just tried to click there and it didn't work? It's because I didn't go back to my cursor in the draw tool, so I can't tell you guys that enough. Now it goes. Okay, so when the electromagnet is turned on, it will have a blank. It will have a magnetic field. Okay, moving a blank against a blank, so you guys need to think about which words you guys can do to fill in. After this blank here, you guys kind of continue your sentence over here. Okay, when you guys have finished pulling out all your little vocab words, I want you guys to read back through. Does that make sense? Okay, A, does it make sense scientifically, and does it make sense in terms of English and writing? Okay, so go through that, read if it makes sense, and then you guys can go ahead, skip all the purple slides, go down to slide 33. Do you have any questions? Circle yes or no. If you have a question, type it right here. Obviously, if it's something that's preventing you from completing this assignment, you guys need to let me know right away. Okay, and then finally, 4, 3, 2, 1, how do you think you did on this assignment? Okay, after you guys have finished that, I want you guys to go back to slide 4, and I want you to just really double check. Did you guys do everything? 2, 3, 17 through 25, and 33. Once you guys have that done, you guys are free to turn it in and have a wonderful day. I'll talk to you soon.